Welcome to my YouTube channel QAQC and NDT, where I would like to share some of my experience with you guys regarding mechanical construction project. Today I will discuss about PWHT, which means post weld heat treatment. We cover the four topics about post weld heat treatment. First, what is PWHT, why PWHT required, PWHT requirement as per ASME Section 8 Division 1, and PWHT for CS and low alloy steel P number 1 grade 1, 2, 3, 4. The first question is, what is PWHT? The answer is a method for reducing and redistributing the residual stress in the material that have been introduced by welding. The need of PWHT is mostly due to residual stresses and microstructure changes that occur after welding. During the welding process, a high temperature gradient is experienced between the weld metal and parent metal. Post weld heat treatment is a controlled process in which a material that has been welded is reheated to a temperature below its lower critical transformation temperature and then is held at that temperature for the specified amount of the time. Codes like ASME specify the specific requirement for PWHT of materials. The PWHT requirements discussed in this document are in accordance with ASME Section 8 Division 1. ASME Section 8 Division 1 specifies the PWHT requirement for material used in equipment designed as per ASME tables UCS 56-1 through UCS 56-11 is ASME Section 8 Division 1 provides heating cycle data required for PWHT of material based on P number and grade number is categorized in ASME Section 9. Those tables are followed by notes which provide exemptions. Table UCS 56-1 gives alternative heat treatment requirement for carbon and low alloy steel before applying for the detailed requirement and exception. Satisfactory weld procedure qualifications of the procedure to be used shall be performed in accordance with all the essential variables of ASME Section 9, including conditions of post-weld heat treatment. The second question is, why PWHT is required? Answer: post-weld heat treatment is applied to steel assemblies primarily to reduce the likelihood of brittle fracture by reducing the level of tensile welding, residual stress, and by tempering hard, potential brittle microstructure regions. Typically, PWHT is used to reduce the residual stresses and enhance the resistance to brittle fracture. Additionally, PWHT can also lead to metal strength enhancement and hardness reduction. Stress relieving and post heating are the most commonly used PWHT procedures. Application and code requirement as well as service environment primarily drive the need for PWHT. Post weld heat treatment requirements as per ASME Section 8 Division 1. The first point is, except as otherwise specifically provided in notes of table UCS-56-1 through UCS-56-11 or table UCS-56.1. Wall welds in pressure vessels or pressure vessel parts shall be given a post-weld heat treatment at a temperature not less than specified in those tables when the nominal thickness including corrosion allowance exceeds the limit given in those tables. The next point is, when the minimum design metal temperature is colder than -50 degree Fahrenheit and the coincident ratio defined in figure UCS-66.1 is 0.35 or greater. PWHT is required, except that the requirement does not apply to the welded joint in vessel or vessel parts fabricated of P number 1 material that are impact tested at the MDMT. The exemptions provided in table UCS-56-1 through UCS-56-11 or table UCS-56.1 are not permitted when PWHT is a service requirement set forth when welding ferrite material greater than 3 mm thickness with the electron beam welding process, or when welding P number 3, P number 4, P number 5A, 5B and 5C, P number 10 and P number 15E material of any thickness using the inertia and continuous drive friction welding process. And the next, electroslag weld in ferrite material over 38 mm thickness at the joint shall be given a grain refining heat treatment. Next, electrogas weld in ferrite material with any single pass greater than 38 mm shall be given a grain refining heat treatment. When pressures part of two different P number groups are joined by welding, the post-weld heat treatment shall be of the material requiring the higher post-weld temperature. When non-pressure vessel parts are welded to pressure parts, the post-weld heat treatment temperature of the pressure parts shall control. Most commonly used material for process equipment comes to under P number 1, grade number 1, 2, 3, 4, PWHT for carbon and low alloy steel P number 1 and grade number 1, 2, 3, 4 are given. PWHT for carbon and low alloy steel P number 1 and grade number 1, 2, 3, 4. The answer is welded joint over 38 mm nominal thickness. For welded joint over 32 mm nominal thickness through 38 mm nominal thickness, unless preheat is applied at a minimum temperature of 95 degrees Celsius during welding. This preheat need not be applied to SA841 grade A and B, provided that the carbon content and carbon equivalent for the plate material by the heat analysis don't exceed 0.14% and 0.40%. The second point is for groove welds not over 13 mm size and fillet weld with a throat not over 13 mm that attach nozzle connection that have a finished inside diameter not greater than 50 mm, provide the connection do not form ligament that require an increase in the shell or head thickness, and preheat to a minimum temperature of 95 degrees Celsius is applied. The next, for groove weld not over 13 mm in size, for fillet weld with a throat thickness 13 mm or less that attach tubes to a tube seat when the tube diameter does not exceed 50 mm, a preheat of 95 degrees Celsius minimum must be applied when the carbon content of a tube side exceed 0.22%. The next point is for groove weld not over 13 mm in size or fillet weld with a throat thickness 13 mm or less used for attaching non-pressure part to pressure part, provide preheat to a minimum temperature of 95 degrees Celsius is applied when the thickness of the pressure part exceeds 32 mm. The next point is for studs weld to pressure parts, provide preheat to a minimum temperature of 95 degrees Celsius is applied when the thickness of the pressure part exceeds 32 mm. The next is for corrosion resistant weld metal over Lay cladding or for weld attaching corrosion resistant applied lining CuCl 34. Provide preheat to a minimum temperature of 95 degrees Celsius is maintained during application of the first layer when the thickness of the pressure part exceeds 32 mm. Thank you for this watching my YouTube videos QA/QC and NDT, which I described about PWHT, and I will try to prepare a new video for another topic. Thank you so much for watching.